Parametric, adjective, any of a set of physical properties whose values determine the characteristics or behavior of something. Like drilling holes, countersinking holes, tapping holes. Hard tapping holes, perhaps? Yes, folks, it is finally here. True hard tapping. This might well be the most valuable feature to bring to the benchtop from full machining centers. You saw the video of the motor controller switching back and forth from spinning to indexing. You saw the video of the fourth axis doing hard tapping. So how are these all related? You'll see in a minute. The motor controller has now been adapted to run a servo-controlled spindle and brings the same indexing spinning capabilities to the spindle. Parametric macros take advantage of these. In just a few seconds, you are going to see both the capability created by the controller and also the parametric macros working with the controller. At the end of this video are links to the macros and the G-code used in the video. Think of parametrics as if you had a skilled helper who knew exactly how to build a doghouse. You just tell the helper, "I want a doghouse for a 40-pound dog, please," and you're done. The helper then calculates everything needed and proceeds to build you a complete, appropriately sized doghouse. What you're about to see is not a canned G83 cycle. It's a parametric macro that calculates each peck and performs every move based on parameters that you give it. Well, so far that's no more than G83 does, so what? May as well just use G83. After this, we'll see two more processes that G83 cannot do. Once you've mastered the concepts of using variables, using subroutines, writing macros, scripting, you'll be able to do a lot of things that G-code alone cannot do. What you're seeing here is initiated using the following line in the G-code program. M9001, P minus 0.7, Q 0.15, R 0.2. Same as G83 so far, but it gets better. G83 is great for small drill bits like this, but what about bigger drills in gummy materials like aluminum, where you need to break the chip very frequently but only clear the hole occasionally? Be nice to have a canned chip breaker in addition to the peck. Well, alrighty then. A few small changes to the peck macro, and now we have a shiny new parametric chip breaker macro. This video needs countersink next and not big drills, but to show the chip breaking motion, that actual parametric macro is being used for the countersinking. This function is initiated with the following line. M9002, P minus 0.12, Q 0.06, R 0.2. P equals depth of the countersink, Q equals distance between breaks, R equals retract Z. Note that for countersinks, the depth includes moving the tool into the hole. The cut is only 20 thousandths. Grand finale coming up. something I've wanted for a long time. Hard tapping. Yeah. Once you have your parametric macro in place, this is how easy it is to do any tapping job. M9000, P minus 0.45, Q 28, R 0.2. Q equals threads per inch. Truly a mini machining center. Tap 5 holes in a few seconds. In addition to the phenomenal increase in productivity, no more, or at least a lot fewer, shattered taps. Actually, it gets even a little better. Another parameter will be added to tapping, max amps. This will tell the servo drive how hard to push the tap so that if it gets clogged and stuck, or just gets too dull, the drive will fault and e-stop the system instead of breaking off the tap. Usually the tap breaks off in the last hole of a part that took an hour to make. Extracting a bottomed out spiral tap is about impossible, so the part is often also ruined. Okay, that's it for this video. The servo-powered spindle has been a long time coming, but finally we had time to get it done. Links will be added to the video description as soon as we can get the stuff uploaded. Thanks for watching.